Hey team, it's Mr. Z, and today we're going to look at solving some radical equations. Let's go ahead and dive on in. So I'm going to give you an example of an equation that you might have to solve. It's going to be x plus 2 squared minus 1 equals 8. Now there are two methods you can use to solve this equation, and it all depends on your frame of reference. Some of you might want to expand the x plus 2 squared. So in order to do it this way, I'm going to rewrite this equation as x plus 2 times x plus 2 minus 1 equals 8. I'm going to go ahead and multiply out the binomials, resulting in x squared plus 4x plus 4 minus 1 is equal to 8. I'm going to continue to simplify, and the number of terms is going to decrease. Now, when I'm solving quadratics, it's important that this last number be 0. The reason being is this is what enables us to solve complex equations, the zero product property. So in order to get there, what I need to do is I'm going to subtract 8 from both sides. This is going to result in x squared plus 4x minus 5 equals 0. And notice how it's in standard form on the left. I can make some conclusions. However, what I'm going to do is simply just factor this guy. So I'm going to go ahead and put in my critical information. It's going to be x squared and negative 5. And I'm going to try to go ahead and generate 4x. Since it's a positive, I know that the 5 term will be positive and the 1 will be negative, because positive 5 times negative 1 is negative 5. Likewise, x times x is x squared. When I fill out this and multiply my square out, it does result in a b term that is 4x. Therefore, it is x minus 1 times x plus 5 equals 0. Okay, now you have to think to yourself, one of these numbers have to be 0, either this, case 1, or case 2, where x plus 5 is 0. So this is how I get these two equations. X minus 1 is equal to 0. X plus 5 is equal to 0. And I would use inverses to get my solutions or my x-intercepts. So this has been using factoring and expanded form essentially to simplify this. If for whatever reason I could not factor this, I would use the quadratic formula to get my answer. Now there is another way. Are you interested? For B, this is going to take a look and more about the exponent. I'm going to go ahead and have the same equation, and then I'm going to try to get the x by itself. That's my goal. So I'm going to just start off with order of operations instead of expanding it. It's going to be x plus squared equals 9. Now the key here is if I take the square root of both sides, x plus 2 squared equals the square root of 9. On the left is going to be x plus 2. But remember, the square root of 9 can be positive or negative 3. Thus, getting to my two cases as before. X plus 2 equals positive 3. X plus 2 equals negative 3. I go ahead and get my x by itself, and notice how I get the same solutions. Well, these solutions are correct because they end up being balancing the equation, making the left and the right side equal. So I just want to show you there are alternatives. If, however, you get stuck and this square root isn't necessarily a nice number, you might want to resort to the quadratic formula. So in order to practice this, I highly recommend you pause and take a moment to try these two problems. I would try negative 2 times x plus 2 squared equals negative 32. And then the second one I would like you to try is 2 times x minus 1 squared plus 1 is 19. So hope this helps. This has been Solving Radical Equations. Good luck and God bless.